Good day. I am Hans Mitchell, Managing Director of Innovative Recycling. The aim of this DVD is to give you an overview of our waste tyre site in Pretoria and to demonstrate the process of pyrolysis and distillation or cracking. Innovative Recycling is a South African-based company. Marketing in other countries are done by means of joint ventures and partnerships with local companies. Innovative Recycling has the sole distribution rights for the waste tyre and plastic conversion to fuel plants for Africa and Europe. Innovative Recycling has patents registered for the combined process of pyrolysis and cracking. With this technology, Innovative Recycling can address any country's waste disposal problem of rubber, plastic and any other fossil fuel products by means of this technology. This is done in every country with the partnerships that we form with a local company. Countries like South Africa faces a huge disposal problem with tyres. This is waste tyres that were delivered to our premises by tyre companies over a 6-month period. These are the two pyrolysis reactors, the condensating pond, and lastly to the left the distillation plant. From the stack, tyres is brought closer by the workers by rolling it towards the reactors and the opening for loading. Tyres are thrown and rolled into the reactor through the door opening at the front of the reactor. One load of the reactor is plus minus 5 tons. After fully loaded, the door or the hatch is closed. The door is tightly closed so that no oxygen can get in or any of the gases that get created can leak out. This is the electrical control panel from where all the electrical operations are controlled. The process is started and the inside part of the reactor is slowly turning. The heating is done by oil and gas burners and controlled from this control panel. The two burners to the left and the right are the oil burners and the two in the middle are the gas burners. This is the flames from one of the oil burners. You can clearly see how it actually goes around the whole reactor to start heating it up. By raising the temperature to about 300 degrees, the rubber starts gasifying and the gas moves through this pipe into the catchment tank and then over into the bigger pipes on the top to the cooling pond. The process is controlled by temperature and pressure. The gases move from the catchment tank through the pipes to the cooling pond, where the gases will be cooled down inside the condensators to form oil. This is an aerial view of the cooling pond. Under the water you can see the condensators where the oil is formed. From the cooling pond and the condensators, the tyre-derived oil flows to the catchment tank through a process of gravity feed. Extra gases not converting to oil flows through these pipes into this catchment tank. The gases in the tank is then used in the gas burners to further heat the plant. By this time, when there's gases available, the oil burners is then stopped and the whole plant runs on its own gases. You can see here it flows from the tank through the pipes to the two middle gas burners. When the pyrolysis process is finished, the lid in front of the reactor is opened and the steel is pulled out. The steel sticks together and then it's baled afterwards and sold to scrap metal dealers. When carbon black is taken out of the reactor, it falls into this trolley, and from here it can be bagged. The carbon black is stored in these big bags, and here you can see the carbon is a black fine powder. In summary, the tyres is loaded into the two reactors, heated by the oil burners and gas burners until it forms a gas. This is the gasifying of the rubber. That moves through to the condensators, which cools it down, and then tyre derived oil is formed and then stored into the storage tank. Extra gases, not turned into oil, is then fed back to the gas burners for heating of the plant. The statistics of the plant are as follows. In a 30-day month, with 3 shifts a day, using the 2 reactors and 5 tons of tyres into each reactor per shift, that would give you a loading capacity of 900 tons per month. 45% of this is turned into tyre derived oil, 40% into carbon black, 10% into steel, and then 5% of the gases not used in the system is used for heating of the plant. From the 900 tons of tyres that is put through the system per month, 405,000 litres of tyre derived oil will be formed, 360 tons of carbon black, and 90 tons of steel. The distillation process consists of exactly the same components as the pyrolysis process. There's a reactor which is heated in the same way with gas and oil burners. Then instead of going through condensating, it goes through a cracking tower which is cooled down with water out of the pond. That eventually gives tyre derived fuel into the storage tank. Tyre derived oil is pumped from the storage tank into the reactor for processing. The distilling plant got the same air filtering systems, the catchment tank for the gases, but then it feeds it into the cracking tower, which is on the middle of this picture. Tyre derived fuel got the same type of properties as diesel. If you've got tyres available that is bigger than car and truck tyres, that is normally earth moving and mining equipment tyres, you will need a cutter or resizer to cut these tyres into handleable pieces. We've made an agreement with Tippytone, a company that have manufactured a machine like this to cut bigger tyres into handleable pieces for processing. In this DVD clip, it is demonstrated how a earth-moving equipment tyre is cut into handleable pieces and is then ready for processing in our pyrolysis reactor. If you are interested in the concept that we demonstrated in this DVD, please feel free to contact us on the numbers that will follow. I would like to thank you for the time spent watching this DVD. Goodbye.